Hi, let's continue with the discussion on the topic of division with remainder. Let's work out an example together. Find the quotient and remainder when 4096 is divided by 23. Write an equation that expresses the relationship between the dividend, divisor, quotient and remainder. Remember, 4096 is called the dividend, 23 is called the divisor, and what we're looking for is we're looking for the maximum number of multiples of 23 in 4096. And then we count after we covered the maximum number of multiples in 4096. We'll look to see if there's a remainder, if there are any more whole numbers that we have to get up to 4096. So in other words, we're looking for an equation of this type. 4096 equals the maximum number of copies of 23, and if that number doesn't equal up to 4096, if it falls short of 4096, that means this number, the maximum number of copies of 23, when you calculate this number, if it's still to the left of 4096, we count the whole numbers that up to the 4096, and that we write as the remainder. Remember, the remainder can be is any whole number between 0 up to 23, but not including 23. Because if it were 23 or greater, that means you could have one more multiple in here. So our task now is to figure out what is this maximum number of copies of 23. In other words, what is this quotient and what is this remainder. So let's do that on the other board. So here's 4096 divided by 23. We are looking to fill in these blanks. What is the maximum number of copies of 23 present in 4096? And so this number would be the quotient, and we're looking to fill in a number. It could be 0, 1, 2, 3, any number, but only up to 22 can go in this spot for remainder. So how do we go about arguing with this one? Do we have any 4-digit number copies of 23 in 4096? The smallest 4-digit number we have is 1000. Well, if you multiply 23 by 1000, we go well over 4096. So there are no 4-digit number copies of 23. Next, we look for 3-digit copies of 23. The smallest 3-digit number is 100. So we do this calculation, 100 times 23, which is 2300. Then we ask ourselves, how about 200 copies of 23? Would that work? Does 4096 have 200 copies of 23? A simple calculation will show you 200 times 23 is 4600. We go over it. So we can mentally estimate the maximum number of copies of 23s between 100 and 200. So here we have 100 copies of 23 is 2300. So what we do is we do the subtraction, 4096 minus 2300, and I'll leave it up to you to do this calculation. We get 1796. So we say to ourselves, 100 copies of 23 gets us up to 2300. We still have 1796 more numbers, and in that number we're looking for copies of 23. So this time we look for 2-digit copies of 23. The smallest 2-digit number is 10. 10 times 23 is 230. Then we ask, how about 20 times 23? Would that work? And you can do those mental calculations until you get up to 70. 70 times 23 is 1610. If you do a calculation 80 times 23, you will go over 1796. So now we estimate, so now we calculate 70 times 23 is 1610. We do the subtraction as before, and now we have 186. So what we say to ourselves is, we can, in 4096, we have 170 copies of 23. We may have even more. We definitely do not have 180 copies of 23. So we have an estimate. this number is somewhere between 170 and 180. And now we zoom in and ask ourselves, in 186, do we have any more copies of 23? Well, this time it will only be single digit copies of 23. So you can try out a few trial numbers for the single digit up until you get to 8, and you'll see 8 times 23 is 184. If you were to do 9 times 23, you would go over 186. So 8 is the good number for us to keep. So 8 times 23 is 184. We write it here. Now we have 2. So what does this whole process mean? It means the maximum number of copies of 23 in 4096 is 100 plus 70 plus 8. So that's 178 copies of 23. And if you do 178 times 23, you'll get close to 4096. You'll be 2 away from it. You'll be 2 less than 4096. So 2 is the remainder. So let's write that down now. So 178 and 2. So that means in this division with remainder problem, quotient is 178 and remainder is 2. So these discussions will slowly lead up to what we call the long division algorithm. Thank you.